We're going to look at case F, the one involving the dice and a coin toss. If you have not attempted this problem on your own, stop this video and make sure you try this on your own first. Otherwise, you're not going to get as much out of these if you haven't tried some of them. In each case, I'll come up with a way of thinking through the problem, but once I show it to you, the problem will be revealed perhaps in a way that if you can't learn to conceptualize these, you're not going to get the greatest benefit. So try each of these problems before watching the video. Assuming that you have attempted this problem, I'll show you the way I visualize this problem. First, I needed to come up with some way to depict this. And if you could use an event tree, but that becomes a very involved event tree with about 12 branches in the end. So instead what I'm going to do is I'm just going to look at the different outcomes that you could have with the roll of the die, and those possible outcomes are a 1, a 2, a 3, a 4, a 5, or 6. And in some cases we're going to be having a coin toss. So there will be sometimes a head or a tail or no coin toss. Remember that for even numbered problems, we just record that score. If we have an odd number, then we toss the coin. So in fact, I'm going to draw this in essentially a Venn diagram format, where I'm going to have each event in a rectangle instead of my typical oval, and I'm going to have the rectangle fully occupy this space here. So this will be my Venn diagram. That'll get this big. And together, all the probabilities will occupy that entire rectangle, and we know then that they'll sum to 1. So we'll get started. In the case of a 1 being tossed by the dice, then we're going to toss a coin, and we're either going to get a head or a tail. And according to the problem statement, if the head is, if we get a head, then the score is the number on the die. But if we get a tail, then the recorded score is twice the number on the die. So in the case of a head, our score is a 1. In the case of a tail, we double that score and get a 2. Then if we roll a 2, we don't toss the coin, and we just record that score. So I'm going to make a rectangle twice the size of the earlier one, and because it's twice as likely, because I don't have to worry about whether it's head or tail, I'm not going to have a coin toss, so it's going to have a probability of 1/6 essentially. Next, we're going to look at 3, where if we get a 3, we have a 1/6 probability of getting a 3, but then, whoops, if we get a 3, we're going to toss the coin, and we could have a head, in which case we just record the 3, or a tail, in which case we record a 6. Then we get the case of the 4, in which we get a 4. And for 5, we again have the coin toss, where we'll get either a 5 or a 10, and if we get a 6, then our score is a 6. So the large rectangles have a probability of 1/6, and the smaller, almost squares, we have a probability of half of that, or 1/12. And if you add those up, then we have 2/12 for these first two boxes. Oops. Then we get another 2/12, so we get 2, 4, 6, 8, 10, 12 twelfths in total, and yep, our probability is 1. With that, I think we're now ready to answer the questions. And the first one asks us, what are the possible outcomes? The possible values of the recorded score? Well, we see here that they include 1, 2, 3, 4, 5, 6, and 10. Those are the possible scores from our setup. In B, it asks, what's the probability that the score is 10? Well, that was just one of the small boxes, so the probability is just 1/12. And you could represent that in digital form, but there's really no need to. We can just leave it at that. And then we get to question C, which is asking, what's the probability of a score 3? Well, the 3 is also one of the smaller rectangles, so it's a probability 1/12. And then we get to part D, and in D, we're asked, find the probability of a score of 6. Well, we can get a 6 in two ways. We either roll a 6, or we roll a die, the die hits a 3, and then we get a tail. So we have those two different rectangles that we have to add up. The larger one is 2 twelfths. The smaller one is another 1 12th. So we have 3 twelfths or 1 fourth, 0.25. So that's our answer for D. Then E, what's our probability of getting a score of 4? And here we only have the single large rectangle, so that probability is 1/6 or 2 twelfths. And then we get to F. F's the one that gets a little tricky. We have a little more work to do. If the score is a 6, what is the probability that an odd number was obtained on the die? Wow. So there are two different ways of getting a 6. And what this is asking us for is, what is the probability that we got an odd number on the die given that we got a score of a 6? To get that, we're going to use our definition of conditional probability, and that'll be the probability of it's odd and 6 divided by the probability of getting a 6. So we can get a 6 by rolling the die and getting a 6, or by rolling a 3 and getting a 6. So the only one that would be odd and get a 6 would be the smaller rectangle, which has a probability only of 1/12. And what's the probability of getting a 6? Well, we already calculated that back up in D. It's 1/4, so that's 3/12. And with that, then you can see that this answer to this is just the 12s cancel out, and our answer is 1/3. So that's our conditional probability that the problem asked for, and that's this case F.